In this video, we'll talk about sequence and how to find its general formula or the end term. Let's start from the easy ones like sequence containing even numbers. The general formula of this sequence is given by 2 n minus 1. When you start from 0, you add minus 1 here. But if you start from 2, then you simply write only n. So we have 2n. The n here is the counting numbers. So it starts from 1. The first term of the sequence, that is where your n is 1. Let's check this out if this sequence really works. So when your n is 1, you have 1 minus 1 is 0. 0 times 2 is 0. So you get the first term. When your n is 2, for the second term, 2 minus 1 is 1. 1 times 2 is 2. We got the second term. When your n is 3, 3 minus 1 is 2. 2 times 2 is 4. We got the third term. You can continue the rest of the term to verify it. Next, if we have a sequence which contains the odd numbers, like 1, 3, 5, 7, 9, so on and so forth, then the general formula of the sequence is 2n minus 1. We can verify this. If your n is 1, we have 2 times 1 is 2 minus 1, we get 1. When your n is 2, 2 times 2 is 4 minus 1 is 3. n is 3, 2 times 3 is 6 minus 1 is 5. And you can verify the rest of the terms. Anyway, we can also simplify this. If you want to simplify it, it's going to be 2n minus 2. It's the same. Let's go to the terms that is an arithmetic sequence. Arithmetic sequence are sequence which has a common difference. Okay, say for example, it will start from 7. Then say for example you add 5 for the next term, you get 12. Then 12 plus 5, you get 17. And plus 5, you get 22. Plus 5, you get 27. So on and so forth. So this sequence where you have a common difference of 5, you add 5 successively for the next terms. There you go. Now, how will you get the formula of these types of sequence? The general formula is easy. You just simply copy the first term, which is 7, and then you add the common difference, which is 5, and you multiply it to n minus 1. Okay, so you can check this out. If your n is 1 for the first term, 1 minus 1 is 0. So this term here is 0, so we get 7 for the first term. For the second term, that's your n is equal to 2. 2 minus 1 is 1 times 5 is 5 plus 7 is 12. Third term, n is 3. 3 minus 1 is 2. 2 times 5 is 10 plus 7, 17. You can verify the rest of the sequence. Next, we can simplify this as well if you want to write this in simplest form. So you have 7 plus 5n minus 5. So this is 2 plus 5n. Next, If your common difference is negative, like for example 8, let's start from bigger number. So 8, suppose we subtract negative 3, we minus 3 for the next term. So 28 minus 3 is 25, minus 3 is 22, minus 3 is 19, so on and so forth. So that means the common difference is negative 3. So if you have a sequence like this, it's still the same. You pick the first term, which is 28, and then you add the common difference. So that's minus 3, and then you multiply it by n minus 1. You can verify it when your n is 1. This is 0, so this term becomes 0. We get 28 for the first term. For the second term, your n is 2. 2 minus 1 is 1 times negative 3 is negative 3. 28 minus 3 is 25. Okay, and you can verify the rest of the terms. You can also simplify this. This is 28 minus 3n plus 3. So 28 plus 3, that gives you 31 minus 3n. There are sequences that don't have the common differences, or it's not an arithmetic sequence. Say for example, we have 6, 7, 10, 15, 22, 31, so on and so forth. So as usual, the first thing we check is the differences of of each term to the next. So we have 1 here. Difference here is 3. This is 5, 7, 9. So the differences forms the odd numbers. So what I'm going to do here is, let's check the cumulative sum, or the series of these differences. We have 1 plus 3 plus 5 plus 7 plus 9. Next is, let's check it out, the sum of this one by one. For the first term we have 1, if it's the only one. If we add the two terms, 1 plus 3 is 4. We add the three terms, 4 plus 5 is 9. If we add next term, we have 16. Continue, plus 9 is 25. So observe that we have perfect squares here. Like 1 is 1 squared, 4 is 2 squared, 3 squared, 4 squared, 5 squared. So we can now deduce that the cumulative sum of this, if this goes up to n, it's gonna be n squared. So this is the cumulative sum. So we can apply it here. It's gonna be easy now. We just only pick the first term, which is 6, then plus the cumulative sum of our differences, which is n squared. Now before writing the n squared, since our n starts from 1, if this is 1, then we have 1 squared, and 1 squared is 1. 1 plus 6, 7. So we don't add the first term. So we have to adjust it a little bit. So n minus 1 squared. So that when our n is 1 for the first term, this is 0. And we have 6 as the first term. When your n is 2, 2 minus 1 is 1. And square it is 1 plus 6 is 7. When n is 3, So this is 2 here. 2 squared is 4. 4 plus 6 is 10. So that's it. This is the general formula of this sequence above. Now, suppose we have this sequence 3, 5, 9, 15, 23, so on and so forth. Okay, as usual, the first thing we do is to check the differences. This is 2 here. We add 4. We add 6. We add 8. So we can see that we keep on adding even numbers. Let's check the cumulative sum of this one, which is 2 plus 4 plus 6 plus 8, so on and so forth. Now, what we're going to do, we factor out the 2 of this series. So we have this 1 plus, factor out the 2 here, it's going to be 2. Factor out the 2 here, it's going to be 3. 4 plus, okay. Now we can simply see that this is just sum of consecutive counting numbers. So if you remember the mathematical induction formula of this one is n times n plus 1 over 2. You can verify it when your n is 1. This is 1 here, then 2. 1 times 2 is 2, divided by 2 is 1. That's the first term. N is 2. You have 2 times 3. That's 6, divided by 2 is 3. So we have 1 plus 2 is 3. You can verify it. Now, this is the cumulative sum of this series here. We still have 2 outside, so multiply it by 2. Here 2 can be cancelled out, so we have n times n plus 1, which is the cumulative sum of this series here, or this one. Now, then it's going to be easy. You just pick the first term, which is 3, and then you simply add the cumulative sum. Okay, now we have to adjust it a little bit, because when your n is 1 for the first term, it's going to be 1 and 2 here. 1 times 2 is going to be equal to 2, and we don't have the 3 as the first term, so we have to make this 0 when n equals 1. We have to adjust it. We subtract 1 to our n, and then n plus 1 minus 1 is just n. Okay, so there you go. We can check it when your n is 1. So 1 minus 1 is going to be 0 here, so we have 3 as the first term. When your n is 2, 2 minus 1 is going to be 1 times 2. So 1 times 2 is 2, plus 3 is 5. When your n is 3, it's going to be 2 here, times 3, that's 6. 6 plus 3 is 9. So you can verify the rest of it. Now, you can still continue to simplify this general formula. So we have 3 plus, distribute our n, that's n squared minus n, or it's now, let's arrange it, n squared minus n plus 3. So this is the general formula of this sequence here.